Hi girls, so tomorrow we're going to be learning about the relationship between roots and coefficients. And this is something that we've already done for quadratics. So if you remember, for quadratics, we had that the sum of the roots, alpha plus beta, was minus b on a, and the product of the roots, alpha beta, was c on a, where the quadratic is ax squared plus bx plus c. We're doing exactly that again, except now we've got three roots, the three roots being alpha, beta, and gamma. So you can see up the top here that I've expressed the quadratic. So this is the cubic. This is the most general way to express a cubic with the roots alpha, beta, gamma. I need that a out the front in case it is a not monic polynomial. And what I've done is I've then expanded. Here I've started by just expanding the first two brackets as though it was a quadratic, and then I've gone again and done FOIL, and I've skipped an algebraic step, but I'll show you this again on the board tomorrow. And I've grouped all of the coefficients. So I've grouped the x squareds, the x's, the constants, and the x cubed. And then what I'm going to do is I'm going to compare this to the standard cubic, which is just like the quadratic, and I'll cheat. So that becomes x cubed, that becomes x squared, that becomes cx, and that becomes d. So I'm going to compare coefficients. So of course, I'll start by comparing the x cubes with the x cubes. Right, so the coefficient of x cubed, as you see there, is a equals a, which is what you would expect, otherwise you've made a mistake. We then go through to the coefficient of x squared, which says that minus a times alpha plus beta plus gamma equals b, which a little bit of algebra tells me that alpha plus beta plus gamma equals minus b on a. And I want you to notice, please, that this is exactly the same as in a quadratic, which is alpha plus beta equals minus b on a. And in fact, that will hold no matter what power of x we talk about. It'll always be, and we might prove this in class, we'll see how we go, that the sum of the roots, however many they are, is always minus b on a, if you start by ax to the n plus bx to the n minus 1 plus so on, and so on. And you might be able to see it here in the expansion, but I'll try a bit better to convince you of that tomorrow. But for now, I just want you to notice that we start, if we consider this the starting point, they are exactly the same. And that's how we're going to remember it. Well, that's how I remember it anyway. So if I go to the next step and I look at the coefficient of x squared, I get this equation. Again, I divide by a to get that. So this is called the sum of the roots in pairs. So we started with the sum of the roots. Now we've got kind of the sum of the roots in pairs. Like the the degree 2 equivalent is the product of the roots is c on a. But now it's the product of the roots on pairs is c on a. So notice the pattern. B has changed to C, and it's gone from minus to a plus. If I now look at the constant term, and again I do exactly the same thing, I divide by, this time minus A, I get alpha, beta, gamma equals minus D on A. So now the product of the roots in triples, instead of pairs, or just the product of roots, is minus D on A. So again, the C, I'll go back, the C has changed to a D, and the plus has become a minus. That's how you remember the pattern. Okay. All of the question types that you've seen before, we will be redoing. They get a little bit more challenging because of the fact that there's three things and because it's an extension one only concept. But otherwise, I think you'll find this topic okay. Okay, so here comes the photo, and I'll see you tomorrow afternoon. Thanks, girls.